Hi, everyone, and welcome to the first ever Women on Stage conference. Thank you for being here. I'm super excited to be here, and I'm thrilled to have all of you joining us. My name is Moran Weber, and I'm the CEO and founder of Women on Stage. And for those of you who don't know us, Women on Stage is a global community platform to showcase, book, and train women professional tech speakers for any event, conference, meetup, or webinar. The platform was launched in May 2020 and achieved overnight viral success, already making it one of the largest databases in the world for women professional tech speakers. Our mission statement is to amplify women's voices everywhere and to create a world where women make at least 50% of tech speakers, because we believe that if you can see it, you can be it. Apart from the platform, 3 months ago, we've also launched the Women on Stage Academy course, which is a full-blown course to train the next generation of women on stages. And for the next 2 days, we are having our ending conference where each of our 40 graduates will present their talks on 2 parallel tracks after they've been building and polishing their presentations throughout the course for the past 3 months, after getting personal tailored feedback from world-class speakers. Our speakers are working in senior positions in some of the best-known tech companies in the world. On top of that, we also have 4 keynote speakers opening each track, 2 today and 2 tomorrow. Our speakers are going to present highly technical, professional sessions covering data, machine learning, NLP, backend, cloud and big data, frontend, React, software languages, software architecture, and many more. Before we start, I'd like to thank all of the people and the companies who made this course and this conference possible. Thanks to all of the awesome sponsors who actively choose to promote diversity as part of their mission. We truly couldn't have done this without you. Be sure to check our job board with lots of wonderful job opportunities. Thanks to Event Handler Productions for producing our conference and to the team organizing the event. Special thanks to Microsoft and the Baot community, which is the largest community in Israel for women in senior positions in R&D, for collaborating with us to turn our first course into a dream come true. Special thanks to all of the course instructors, which are world-class speakers and true legends. And last but not least, to our brilliant and dedicated mentors who accompanied our students throughout the course. All right, so one last thing before we start. You're welcome to join our Slack channel for a chat and Q&A with our speakers. The sessions are pre-recorded, so the speakers are going to be available during their talks to answer all of your questions live. We'd love to hear your thoughts. Ready? So here we go. I used to have major stage fright and considered myself as an introvert for most of my professional life. I remember myself always sitting in meetings in the back. Well, back then, before they were all virtual. Always trying to keep quiet to myself, being too scared that if I speak my opinion, someone will find out that I'm just a fraud, that I shouldn't really be here, that I don't belong. This phenomena is called the imposter syndrome, and for those of you who don't know it, it's very common to many people, and especially to women working in tech. I never could have dreamed I'd be standing here today telling you all about it. I never could imagine I'd become an entrepreneur and be the one behind this conference. If someone would have told me back then I'd be standing on stage, speaking in front of hundreds of people, and start my own company, I would probably laugh to your face. Who? Me? No way. But turns out life has a way of surprising you. And today I would like to share with you my story, my personal story, and of my own journey, and the story behind Women on Stage. Hi, my name is Moran Weber. I live in Israel, and I'm the CEO and founder of Women on Stage. My professional background is in software engineering. I've been working in the tech industry for the past 10 years. I used to work many years at Wix. And other than that, I'm also a social psychologist, meaning I have a master's degree in social psychology and I mainly specialize in gender studies. I'm a public speaker today, and I'm deeply devoted to supporting and empowering women in the tech industry. So, what are we going to talk about today? In the first section of my talk, I will share with you my own personal story and the story behind Women on Stage, and how I managed to overcome my own stage fright and become a public speaker. In the second part of my talk, I will share with you some power tips I've gathered throughout the years that helped me manage my own stage fright and imposter syndrome on stage. So let's begin. That's me in the picture. I look satisfied and content, aren't I? Well, as I've told you before, that was not always the case. I wasn't born a speaker. And let me start by sharing my story and how it all began. So, I've already told you about my imposter syndrome and about my stage fright. I started working in the tech industry in 2010 as a software developer. I was an introvert, mainly trying to avoid drawing too much attention to my direction. I remember when I first heard about this phenomena of imposter syndrome, I thought to myself, oh my God, that's me. But all of these other women, they don't really have it. In my case, it's real. I am an imposter. I really don't belong here. In my case, it's real. So I loved being a software engineer and I was quite good at it. But after a few years, I've started to feel like I'm missing something. Like my career is missing an extra kick. And in 2017, I applied to a women-only presentation skills workshop at Wix. I was working at Wix back then. And this is a point worth mentioning because I've seen it happening multiple times on various occasions. One might ask, why do you need a women-only workshop? The thing is that they used to have these workshops open for all, but there were no women applying. But suddenly, when it was women only, it was suddenly a full house. And I've seen this pattern happening countless times. Same goes for job description, for accelerators, and so on. When you're approaching women directly, suddenly they feel it's much more inclusive and they feel like they're more welcome. Same goes for other underrepresented minorities in tech. So my advice here is to always actively seek the underrepresented and directly approach them if you want to be more inclusive and if you want to include more of them. Anyway, that presentation skills workshop was really a life-changing experience for me. I suddenly felt like I do have something interesting to say. And the entire group was really supportive and intimate. So after that, I actually started speaking in meetups and actually also started and co-founded a very successful meetup series for women in tech called the Women in Tech Forum at Wix. And I actually fell in love with public speaking. I was surprised to find out that I'm pretty good at it, and it started to make my career fly. I felt like I finally found the best way I can speak out and communicate my knowledge in a way that I don't feel like an imposter anymore, in a way that I feel like I belong. And during that time, I also became a mentor for dozens of other speakers and helped them build and polish their presentations as well. I also started to speak at conferences myself, and one time I spoke in front of 800 people at the biggest conference in Israel. It seemed that that my career is on the right track of things. And then, late 2018, exactly 2 years ago, I experienced a huge personal health crisis. I was diagnosed with thyroid cancer. And for those of you who don't know, the thyroid gland is a butterfly-shaped organ located right here on your neck, outside of your throat. And the diagnosis came after a long period of time where I was frequently experiencing throat infections and throat pain. It lasted for many months until I was diagnosed, and I was suffering all along. The pain was so frequent that I was having trouble to speak. I found myself at the age of 33 at the top of my career with a family and a 3-year-old kid at home. But I was experiencing so much pain to speak that I've tried to speak as little as I could. Every word that I said has caused me pain. I remember I used to count words in my head, try to minimize the amount of words I need to say in order to make my message understandable, because it was just too painful. Back then, I truly felt like my voice had been taken away from me. I felt like I've lost my voice. Okay, so you can all relax now. I'm okay. But back then, I've really felt like it's time that I change my life completely. You know, when life gives you lemons, turn them into lemonade. So I've come to realize that this is my wake-up call to do things differently. I've made up my mind that I want to be the change I want to see in the world. So I left my job and started working on the Women on Stage platform. First, it started as a side project because I noticed that there are too many occasions when there aren't any women speaking on tech events. And when you would ask the event organizers why there aren't any women on their list, they would always say, well, we've looked, but we couldn't find anyone relevant, or we couldn't find anyone who knows about these things. And I was really pissed off about that because I personally knew so many of these talented women from the time I was managing the Meetup series. So I decided to build a platform for women to showcase themselves based on their professional knowledge, so nobody will say there aren't any relevant women out there. I launched the platform in May 2020 after the COVID-19 pandemic had already started, and to my surprise, the platform went insanely viral and grew so quickly to hundreds of speakers worldwide. I think it's actually pretty symbolic because after I felt like I've lost my own voice, I have decided to create a platform that will amplify the voices of others. After that, I had a vision. It wasn't enough for me, and I already imagined the next steps. I wanted to build a full-blown course to train the next generation of women on stages. The inspiration came from that very first women-only presentation skills workshop. But I wanted to build something more robust and something more comprehensive. My assumption was that if you take super talented women engineers and push them forward, you can generate amazing new tech speakers and turn the needle for the entire tech industry. I wanted to create the same impact it made on my career for others. But what happened next surprised even me. Because the course started as a pilot, first to validate my assumptions. I never could have dreamed it would be such a huge success. generating such incredible new tech superstars, the next thought leaders of tech. And today, in this conference, you're witnessing these talented women after they've been trained for the past 3 months. Feels like an amazing recap for my journey, and we're just getting started because we're only going to grow. You're going to hear our voices everywhere. 2 years later, and I'm here speaking about it in front of all of you people at a tech conference. And all of these fantastic women are here with me. 2 years later, after I was diagnosed with thyroid cancer, and I've created a platform which showcases hundreds of women speakers in tech to amplify their voices, to make sure our voices are heard. And thank you for being a part of that. So now you know, I'm just like you. I wasn't born a speaker, and I don't think that this is a natural trait that people are just born with. I think you can learn how to become one. And throughout the years, I've gathered a list of power tips that help me manage my own stage fright, and now it's time I share these tips with you. Before we start, let me manage a little bit of your expectations, because I don't think the term should be overcome stage fright. I must admit, I still have it. I'm still always very excited before I go up on stage, even here, even today, even when it's online and I can't really see you and you can't really see me in person. The excitement of being in the center of attention still gets me pumped up and all sweaty. So most likely, you won't really fully get over it. You will probably continue to feel that excitement bubbling up in your stomach. But that's okay. Because I think that rather than expecting to completely overcome that stage fright, you need to learn how to manage it. You need to learn how to use it. We shouldn't let it manage us. We should be the one holding the wheel. You should use that fear and that anxiety to improve yourself, to get better at what you do, and to become much more professional. So what is stage fright anyway? For starters, it's one of the most common and most natural fears. Human beings are social animals. Evolution has made us very susceptible to social judgment. Millions of years ago, those who were excluded from the group were sentenced to death. We live in groups. We are social animals. We need each other to survive. Being at the center of attention is very stressful. Adrenaline is running, our heartbeat is getting fast, our palms get sweaty. It is really scary. Trust me, I know. I'm experiencing it right now as we speak. So don't feel like you're the only one who experiences it. It's super natural. It's so natural that research has shown that many people say that their number one fear is stage fright, ahead of death. And let me read this quote by Jerry Seinfeld. According to most studies, people's number one fear is public speaking, ahead of death, spiders, or heights. Number 2 is death. Death is number 2. Does that sound right? This means that to the average person, if you go to a funeral, you're better off at the casket than doing the eulogy. So, if it's so bad, now what? Don't worry, I've got you covered. And here are my power tips. Number 1, Amy Cuddy, which is a social psychologist from Harvard University, has a very, very famous TED Talk where she tells the story of how she was injured in a car accident. She was told that her IQ had dramatically dropped and she has to quit school. She said that she kept feeling like an imposter, that she doesn't belong here, that she shouldn't be here. So she developed a method for gaining back her powers. She calls it the power pose. So whenever you feel inadequate, you need to stand on the power pose like Wonder Woman, open your chest, pull your shoulders back, and imagine yourself at your best. Take a deep breath. And when she tested it into the lab, she saw that people who stand like that before stressful events like job interviews or before going up on stage actually have lower cortisol levels which is the stress hormone, and higher levels of testosterone, which makes us feel more powerful. So according to Amy Cuddy, don't just fake it till you make it. Fake it till you become it. Number 2, practice. A lot. One of the most critical aspects of becoming a public speaker is to practice. A lot. Out loud. You need to rehearse twice or 3 times more as much as you would probably think you need to. Steve Jobs wasn't born a speaker. He used to practice all the time. Good speakers, TED speakers, they practice their pitch hundreds of times until they remember it all by heart. When you practice something, you learn to prepare yourself for the real thing. When you practice, your anxiety levels are dropping. And when I say practice, I don't mean do it quietly. I mean go to a private room, close the door, and run through your entire presentation yourself, alone, out loud. It may feel ridiculous at first, but you will learn a lot about which aspects of your presentations need more polishing, where you get tongue-tied and need to prepare more. The more prepared you are, the less worried you will be about looking nervous, forgetting your lines, or losing your train of thought. Okay, number 3. You need to practice, but you don't need to memorize it all. Well, actually, you only need to memorize the beginning. We're usually at the top of our excitement at the beginning of our presentation. So when you practice, memorize only the first 3 to 5 minutes of your speech, because after that, you will get more comfortable on stage and the flow will go on its own. There's no need to memorize the other parts because it's too difficult to remember everything. And when you try to memorize too much and if you forget a line, you might get stressed and about forgetting. But actually only you can tell the difference. Only you know if there's something you forgot. Number 4. Sometimes things get bad. Sometimes unexpected things might occur. It helps if you try to imagine the worst that could happen and more importantly, how you overcome it. A few years ago, I saw someone I deeply appreciate. Her name is Ilan Noga, giving a keynote at a big tech conference. For some reason, her slides were missing and there were some technical difficulties. But rather than getting upset and nervous, she started making jokes about it. I admired the way how she handled it. And 6 months later on, when I was giving a tech talk in front of hundreds of people, suddenly my slides weren't loading and my presentation loaded empty. But I remembered what I saw her doing and I did the exact same thing. I used the exact same joke I saw her doing. And it went okay. The audience laughed. I was off the hook. The presentation came back like nothing happened. So always visualize the worst that could happen, but more importantly, visualize your recovery. Number 5, always dry run. Never go up on stage before you dry run with other people. Always gather feedback from people around you, preferably those who understand what you're talking about and care about you. Always ask for a sincere feedback and learn to improve out of it. I genuinely think that this is one of my most important tips. Always gather feedback and don't take it personally. Use it to get better. Things always look differently from how you perceive them when compared to the outside. And number 6, rather than focusing on how people will judge you, shift your focus to what you mean to achieve, to your motivation, your goals, the thing that you want people to take home with them. Remember, it's about them. It's not about you. Another thing you can do is to pretend your fears and your anxiety are actually excitement. Instead of saying, "Oh my God, I'm terrified," construct it differently. Say, "Oh my God, I'm so excited." Even if you're not, even if you're terrified, don't worry. Your feelings will follow afterwards. You need to do this mental shift in order to construct your feelings differently. So let us recap. Number 1, don't just fake it till you make it. Fake it till you become it. Number 2, always practice twice or 3 times more as much as you think out loud, practice out loud. Number 3, only memorize the first few minutes of your talk and not the rest. Number 4, try to visualize the worst that could happen and how you recover from it. Number 5, always dry run before you get up on stage and be open for external feedback. And number 6, try to shift your focus from performance to communication, to your goals, to what you want to achieve. I hope these tips will help you as much as they helped me. And now it's your turn to shine. I invite you all to follow me on social media and to register as speakers on the Women on Stage platform, or register to the next rounds of the Academy on our website. Thank you. Goodbye.
Hi. Welcome to my talk about serverless computing. So I'm Yara. I'm a mother of 3 wonderful daughters. 2 of them are humans and 1 is almost. I'm a full stack developer and a squad lead in CyberArk. In my free time, I like drawing, running, reading, and when possible, traveling. So let's start. Let's try to understand what serverless is. You probably have already heard the buzzword serverless, right? So serverless computing. We can divide the word serverless into 2 different words, server and less. Less server handling on your day work. It doesn't mean you don't have a server at all. It just means that your application will run on a remote server. Running a serverless application, it means that you don't have to purchase a server in order to run your application on it. You will just pay someone else to use their server for running your application on it. Serverless also provides you some backend services, such as data storage, queues for communications, database, and much more. Now I would like to show you a short animation that I have created for this talk that will emphasize the benefits of serverless computing. Let's watch it. Okay. So this is Bob. Bob is a software developer. And this is Suzanne. She is also a software developer. Both of them deployed a management system. Bob deployed it on a local server, while Suzanne deployed her system as a serverless service. One day, the customer found a bug in both Bob and Suzanne's system. So Bob and Suzanne had to fix the bug. And they did it, yay! Now Bob has to build his code, packing it, and deploy it on his local server, while Suzanne only needs to deploy her fix on the cloud. Some time passed, and more customers joined the systems of Bob and Suzanne. Suddenly, Bob's system began to work slowly and slowly. Bob monitored the system and tried to understand what to do. He had to upload more pods and scaling the traffic. And Suzanne is working on a new cool feature, while the cloud provider is scaling up her system. The PO and other customers came with other announcements for Bob and Suzanne's systems. But poor Bob is struggling trying to monitor his system, scaling it up, and now also the new announcement. When will he have time for all of this? And Suzanne, she has much time to work on the new features. She doesn't have to worry about scalability nor maintenance, since the cloud provider does all of this for her. Okay, so let's get back to our presentation. So let's see who is going to benefit from serverless. Here are 4 stakeholders that benefit from serverless computing. The first one is Ed. Ed is our DevOps. He is going to have much more time now, since serverless application is easy to deploy. The scalability and maintenance are taken care by the cloud provider. Next one is Edwin, our CFO. Since serverless computing payment method is pay-as-you-go, you will pay only for the time when your application is executed. While the server is idle, because your application is not being executed, you don't pay. It is like getting a server on demand. Edith is our customer. She is going to benefit from serverless computing because the developers will no longer need to handle the infrastructure, so they will have more time to focus on UX and customer success. And the last one is Eddie, our office cactus. You will have more time to take care of it. So how does serverless work? Serverless is an event-driven compute paradigm. You write your code, upload it, define the triggers, and then an event triggers your code, and your code is running. The code is invoked only when it's triggered by a request. A trigger, for example, can be a change in database, a message that arrived to a queue you're listening to, a click on a website, and much more. These functions can be connected together to create a processing pipeline, or they can serve as components of a larger application. Now let's see the pros and cons of serverless computing. The pros: we as developers don't need to worry about managing machine resources. Deployment is easy and fast. Since we don't have to manage the servers and we don't provide the infrastructure, we don't need to install anything, just compile our code, and the rest is done like a magic. Any fix or a code change can be done very quickly. Just fix the code, compile it on the cloud, and the rest is done by itself, or by the cloud provider, but not by us. Second is pay-as-you-go method. We, or actually our organization, don't need to purchase any server. In addition, we pay only for the resources we use, for the time we use it. No running application, no payment. Another advantage is great UX and happy customers. Since we need to focus only on the application and not handling the infrastructure, we have much more time to improve the look and feel. And this is what matters to customers. They don't care about the work that we do behind the scenes. Next one is better latency. A cloud provider has servers spread all around the world. So if my customer is from Iceland, I will pay for servers in Europe rather than a server in the USA. And the last one, from a global point, less energy is wasted for nothing. These servers are used by many customers at different times. So there are much less empty slots when server runs without any application executed on it. And now for the cons. The first one is debugging. Debugging is more difficult because the serverless is like a black box for us. There are no tools to debug a serverless application. I found myself once digging into so many irrelevant log files until I found the specific one that contained the error I was looking for. You actually need to learn about the log system of your cloud provider in order to debug your end-to-end application. Next one is finance issues. Developers need to think about when to run the application, when to shut it down, and to carefully check the payment method. Otherwise, they will probably waste money for their organization. As a developer, it was the first time that I had to take financial factors into account at work, not at home, of course. Then we have security issues. Uploading your code into a cloud is never as safe as keeping it inside your organization. Your code depends on many third parties, which might contain malicious code, or relies on open source code, which might be problematic sometimes. And the last one, vendor lock-in. When we decide to use one cloud provider, we make adjustments which don't fit another vendor. And finally, when to use serverless. If you want to build a lightweight and flexible application, which is fast expanded and updated, if your application needs to be triggered by different events, if your app don't need to run all the time, and from latency aspect, to be close to your end users. Okay, and now for the exciting part of this talk. I'm going to show you how simple it is to write a serverless application. So before you can start, you need to create an Azure account, install Python, install Azure CLI. And after you've done all of this, you need to sign in to Azure from the CLI by typing AZ for Azure plugin. You can clone the sample that I will show you in a minute. Here, this is the really simple function that I wrote in Python. I used also a Flask, which is a Python framework for web. Okay, so let's see this function. It's called hello. It is called hello. I pass it the name, and it prints to the screen, hello name. Serverless computing is here to stay. Okay, so if we are going to the terminal. Okay, so in order to run my application on my local host, I just need to run flask run. Okay, and then if I'm going here, you can see, hello Yara, serverless computing is here to stay. Very nice, right? But it's not serverless. It is not running on Azure yet. So in order to run it on Azure, I need to run this command. Okay, this command is for the first deploy on Azure. Here I have Azure Web App, and then I gave it the name of the application. I called it Serverless Computing Demo. Okay, it is going to take several minutes. Therefore, I have already ran it, and you can see it here. Okay, here you can see that the URL is Serverless Computing Demo, the name that I gave my application, and it runs on Azure. See, Azure websites. Then hello and Yara, this is my name, and then it prints me, hello Yara, serverless computing is here to stay. Okay, very, very easy. Next time when I'm going to change here something in the code, for example, I don't know, another mark sign, and then I type Command S to save my work. And then in order to deploy it for the next time, for the second time all I have to run is this, okay? And this is not going to take several minutes as before, because this is only to deploy the changes that I've done. Okay, so see, it is very, very simple. You can clone the sample from my GitHub. Okay, it is really easy, simple function. And I wrote here all the instructions. So let's summarize. In this talk, we explained what is serverless computing, who benefits from it. We went over the pros and cons, and we understood when we should use it. We ended with a live demo, and that's all. I really enjoyed talking to you, and I hope you enjoyed as well. And you can contact me via LinkedIn. Thank you for watching. Bye-bye.
Hi, everyone, and welcome to this talk about distributed worker system. My name is Neil Oman, and I'm a backend engineer at Wix. I've been developing software for the past 8 years. I was previously a full stack team leader at a startup doing computer vision and deep learning algorithms called DID. I build systems that scale for a living. My true passion is innovation, tech, and software, and I really love learning anything new. In this talk, I'll present the problem of computing long calculations as part of APIs. I'll tell you all about the solution I found for it, how to make it scale, and how to monitor it. Let's talk about the problem that we're going to solve. I'll start with a small analogy, which I'm sure you could all relate to. Think for a second about all the things you have to do this week. Yeah, I know it's a lot of stuff. We are busy people. Let's talk a little bit about what you have to do this week. So maybe you got to cook, you need to walk your dog, you want to work out, maybe you got some laundry to do, clean the house, and work. So you're busy, but what can you do about it? Well, okay, you have to do your own work and exercise. Nobody can do that for you. But what about the rest of your tasks? Get workers to do your tasks. You don't have to cook. Some people order lunch from Walt. You could hire a cleaner to do the laundry and clean the house. Some people get a dog walker to walk their dog. Where am I going with this? I say APIs are like people. They're busy. Think of them like people. They too have a lot of work to do. Here are some examples to show for it. So they got to create, update, and delete entities. They got to read and write from the database. They got to do authorization and authentication of users. They got to call third-party APIs, and they got to compute long, complicated stuff like deep learning algorithms or some complicated long-running tasks. As I said, I worked at a startup that developed a computer vision deep learning algorithm for 2 years. When the algorithm was finally ready, it took 10 minutes to get the output of it. A very naive solution would be to run the computations as part of the API request. Don't even try that. First of all, you'll get a connection timeout from the client, and second, no user will wait that long. As I've said, we're busy people, and we've got no time to sit and wait for the server to compute for 10 minutes. Hell, I won't wait a second. That was 3 seconds of silence, but it felt like forever, right? So Google recommends aim for a response time of less than 200 millis. Anything over 500 millis is an issue. API's got to be fast. So what's the solution? How could we return a response quickly and still compute long-running calculations? I was required to choose the architecture, the language, and the infrastructure, so I found the following solution for the task of long calculations. Get workers to do your tasks. Let's see how we would solve this in the human case. So this is you, the busy person that creates tasks according to the task you have to get done. This is your assistant. You hired him to write down all the messages that you get to your to-do list. These are your workers that you hired, the dog walker, the cook, the cleaner. They take the tasks from the assistant and get them done. And this is your logbook where you keep track of all the things that you got done this week. Cute story, but how does it really work for a software system? Okay, you guessed it. You're the server. You get the API calls and you gotta respond quickly. Your assistant is really a message broker. It's a first in, first out data structure capable of managing multiple message queues. Distributed workers, they could run in different processes or instances and be scaled according to the workload. They listen to the message broker and perform the task one by one. And the storage, this is the backend in which the results are saved at. Some kind of a database, like a key value store where the key is the task ID and the value is the task result or the task status if it hasn't finished yet. Okay, we have the system design, but which technical stack should we use to implement the solution? After doing some online research, I came to the conclusion that Python is going to be our backend language and Celery should be the tool used to solve the problem of running long algorithm asynchronously. But I've listened to every Celery talk on YouTube and I haven't managed to understand what exactly is Celery and how does it work. So Celery is an open source, asynchronous, distributed task queue. Open source means it can be used for free, and we can see the source code and contribute. Asynchronous means it happens offline, not in the same process that triggered the code. Distributed means it's running on multiple threads or machines or instances, which is exactly what I needed because the algorithm required a GPU to run and could only compute one task at a time. And task queue, we'll dive into that for a second. A task queue is a mechanism to distribute workers' work across threads or machines. Celery's task queue is written in Python, but the protocol can be implemented in any language. This is the code for creating a Celery app in Python. But what exactly do I mean when I say a task? A task is the queue's input. It's a unit of work, which is really just a Python method with parameters. You annotate the task as shown in the snippet. This task has a name, make coffee, and it gets 4 parameters. Once the worker finished computing the task, which means running the code annotated as Celery's app task, the return value is automatically stored in Celery's backend. You can also provide the task with the configurations such as time limit, rate limit, which queue the task should go to, and even set the task priority. You could also set the task to be grouped together into workflows, one task dependent on another or computed in parallel to another. You can set handlers for what happens when a task fails or succeeds. So we now understand what a task is, but what exactly is a Celery worker? A worker is essentially a process that monitors the queue for new work to perform. So once you have a task in the queue, nothing happens. But if you also have workers listening to that queue, one of them will fetch the task from the queue and compute it. Starting a Celery worker is easy, as you can see in the snippet. Of course, you could add a lot of parameters to it, like log level, number of threads, worker's name. Workers can even do scheduled tasks. So now we know what a task is and what a worker is, but how does the task get to the worker? The API is responsible for producing tasks. In the code where you handle the API request, instead of just calling the method makeCoffee, you call makeCoffee.applyAsync with the right parameters. This would behind the scenes put a message in the message broker saying the task needs to be done with its parameters. Then you can return 200 OK to the client that doesn't have to wait for the task to finish and can be notified once the task is done by email or any other way you choose. Cool. We now know what the API does and what the worker does, what the task is, and what the task queue is. Let's take a look at the technical stack of it. Remember this slide from before? So the API is really Flask, which is a very lean Python server framework. The message broker, the best practice for this one is to use RabbitMQ, which is an open source from 2007. The distributed workers are actually Celery workers, and the best practice for storage database is Redis, a key value store which keeps the task results. Amazing, but now you're probably thinking, okay, we have workers to do our tasks, but it still takes 10 minutes. How would we know when the task is ready? At first, we had the Flask API pull Redis every 30 seconds to check the status by task ID. Is it ready yet? Is it ready yet? But that pretty quickly caused Redis thread problems. Keep in mind that Celery task results have a default time to live of Redis for 1 day, after which the results are deleted. Have you got another idea other than polling Redis? We could use webhooks. Have the task itself call the webhook to notify it completed successfully and write the results to a relational database so it's more organized and won't store large amounts of data on Redis, which gets filled up pretty quickly. Okay, cool. And by the way, where are all those components running? If you just want to try it out, the solution, you could run it all on your laptop, install Python, Celery, Flask, Redis, and RabbitMQ, and run the Flask API, Celery worker, RabbitMQ, and Redis. But that's a really bad practice. You don't want every developer on your team to install all of that. We can do better than this. A better solution would be to run each of them inside a Docker container. Redis and RabbitMQ have a ready image, so it's easy to run inside a Docker container. You need to write a Docker file for running the Flask and for running the Celery workers. You should probably have a Docker Compose file to run the whole setup, but we can also do better than this. An even better solution would be to run all of them in a Kubernetes pod, but we could also do better than this. We could run the whole setup in the cloud. You could use Azure, for example, or GCP or AWS. Your workers could run on multiple instances of different types according to which tasks they perform. For example, a deep learning algorithm needs a GPU expensive instance, whereas a task of calling third-party APIs could be done by a regular CPU cheap instance. You can even have instances in multiple clouds reading the task from the RabbitMQ. If you're running on Azure, use AKS. If you're running on AWS, use EKS, or in Google Cloud, use GKE. Awesome. But in this image, we have just 3 workers. How do I control the number of Celery workers dynamically according to the workload? Yep, we need to scale it. We know the workload changes. Daytime, a lot of traffic. Nighttime, less. Weekdays, more traffic. Weekends, less. Maybe on Black Friday, we have sales, and then there's a crazy traffic. So what can we do to enable auto-scaling, to enable scaling? So the very naive solution to scaling a system is just to manually monitor the length of the queue. And once you see there are a lot of tasks, you manually add instances using your favorite cloud provider with your bare hands. It's fast to implement, it actually takes no time to implement, but it's hard work to keep up with the changing load, and pretty quickly you'll forget you scaled up and pay the fine for leaving multiple instances that are very expensive running for no reason. We need something a little more sophisticated. We need an autoscaler. Remember this slide from before? Let's add an autoscaler to it. That would scale according to the number of tasks in the queue. But how? What do we put in this magic box? We need the scaling to be flexible and dynamic because we don't want to pay for workers' instances which we don't need and we don't use. So we need to monitor the length of the queue and add and remove instances according to it. What should we put in this magic box then? It's simple. A Python script that runs every 30 seconds or so and checks how many tasks we have in the queue and sends the API request to the cloud to change the number of pods in the cluster. There are a bunch of pitfalls to this, believe me, but talking about autoscaling can fill an hour talk just by itself. So now we have this simple autoscaler that scales our cluster, so we have as many workers as we need. But it seems that it adds more and more workers. How do we not lose control? Well, that's what they invented monitoring for. How do we monitor Celery? Celery has a monitoring tool called Celery Flower, which allows you to see how many workers you currently have, how many tasks each worker has completed, etc. You can also see the results of the tasks that finished and exceptions of tasks that failed. We also can use RabbitMQ by using RabbitMQ admin UI. It allows you to see how many tasks are waiting in each queue, and you can pop them out of the queue to see their content before they go to a worker. Let's do a quick recap. So we've seen that any API should strive to return a response in less than 200 milliseconds. If your API takes longer, you should consider outsourcing to asynchronous computations. We've seen a solution for the problem by distributing the work among multiple workers that take tasks from the queue. We've seen you can autoscale the amount of workers according to the length of the queue. And we've seen you can monitor it using Celery Flower and RabbitMQ admin. Our workers are doing heavy lifting and long calculations for us so that our APIs could be super fast. So remember that for every 2 minutes of glamour, there are 8 hours of hard work. And it's as true for APIs as it is for humans. We need heavy backend calculations to happen asynchronously in order for our APIs to be fast. Our API respond quickly, but behind the scenes, our workers are doing all the heavy lifting. And if you're too busy, Remember, you can always get workers to do your tasks. I know it's complicated. You can read more about it in my Medium blog that I published, Serving Deep Learning Algorithms as a Service. Thanks for listening, and feel free contacting me.
Hello, everybody. I'd like to talk to you today about how to party with the third-party integrations. My name is Ifat Kohler. I'm a backend developer for the last 8 years, and I currently work at Cloudinary. Lately, I spend a lot of time fiddling with other people's API, and I would like to share with you my thoughts and tips. So, third-party integrations are everywhere, and there's no doubt about it because it gives your application great abilities. Let's think about a family that runs a cake shop, and they want to build a website so they can start getting orders online. The billing flow can be quite a headache, because when you deal with credit cards, you need to think about security. So instead of reinventing the wheel, they can just use an existing billing service that will do all the hard work for them. And if you think about it, there are a lot of other third-party integrations out there that you may have noticed too in your day-to-day life, like when you book a vacation through booking.com. So the event is added automatically to your Google Calendar. So if you think about it, Booking has some integration with Google Calendar. And also, when you sign up to a website like Medium. So yes, you can sign up through the old-fashioned way of defining username and password, or you can just sign up through your Facebook or Google account. And when you do this, it saves Medium the need to deal with user registrations. So let's imagine that you were given a task to integrate your application with a third-party service. How do you even start? Because, well, you have your code, which you are very much familiar with and control of, and you need to connect it with a totally different service, which you may know nothing about their product, have no idea how it's implemented, and have zero control over. So the first step would be to read their documentation. And the documentation should give you a high-level overview of their product. You will see there which different APIs they support, and you should try to understand which of them is relevant to your use case. Look for examples. What the API is getting, what the API is retrieving. And if you've already integrated with different third parties before, you may have noticed that not all documentations are the same. When you work with popular cloud services, you will find a very detailed documentation with a lot of examples. You may find out that other people have dealt with the same use case as you have, and they shared how they did it. However, when you are asked to integrate it with a service that is, well, less popular, pretty new, doesn't have a lot of customers, you may find out the documentation is lacking. When I had this issue, I initiated a virtual meeting with the relevant team members from the third-party application and asked to get an overview about their product. I also explained my use case so they could advise me which of their APIs is the most suitable. Okay, so you've read the documentation and now it's time to try it. Try their APIs. Make sure that it behaves the way you thought it is. And when you would try to do it, the first obstacle you may have is authentication. So in a way, you need to tell them who is doing this API call. And there are many different authentication methods, and this part can fill a whole lecture, so I won't get into it now. But all I want to say is that they need to know which account is performing this API call. And also they need to know it so they can charge you. You could read more about the authentication method in the documentation. So let's say you're okay with that. And now everything worked for you. You understand which API is relevant and you feel so enthusiastic about it and you start coding. And you know where you want to put it in your code, and the API retrieving what you thought, and it works. The functionality is working great. You made it happen. And this is the happy flow. But now we need to think about what happens when things go wrong. We need to deal with the unhappy flow. What happens if they return you an exception? So first, look at the documentation and see which errors they might return. And then try to think how you want to deal with them. I would like to give some examples of popular errors and how I tend to deal with. So the first error is the 400 bad request error. And this error is when you're requesting something weird, like passing impossible value to the API. So how can you deal with that? So maybe you would like to validate the input your user is passing. You don't want to send it directly to the third party. You want to validate it first. But even if you don't want to do it and you want the user to get the exception from the third party, you need to make sure that the exception is informative enough, that when the user will read it, he will understand how to fix it. Okay, so another error is the 500 server error. And this is when something very serious happens. Like the server is down, the DB is not responding, or maybe they have some bug in their software. So what can you do about it? Well, in a way, there's not a lot you can do about it because, well, you cannot go over there and fix their bug. But I would like us to try how to take the most out of it. So if we think about the cake shop from before, if they are getting 500 euro from their billing service, this is a very serious issue because they cannot charge their users. So in this situation, I would have advised to show a message saying, we have an issue with our billing service, but you can complete your order by calling our shop at this number. So this is some solution to this problem. And another error is the throttling error. And it happens when you are sending too many requests to the service, and the service is basically telling you, slow down. So again, it depends on your flow, but if you have an asynchronic flow, like a job, maybe you don't mind sleeping for a while, waiting, and then retry later. So building a retry mechanism can be a good way to deal with this error. And also, I would like to say that you also need to throttle your customers, because you don't want a certain customer of yours to send many requests to the service and prevent other customers of yours to use this service. Okay, great. So we dealt with the errors and now everything is working. You did the happy flow, you did the unhappy flow. Great. But wait, what if they change something? Because the developers are keep working, keep changing the product, also pushing bugs. So what can you do about it? So you cannot prevent them from changing their product and their code. But I think at least you would like to know about it when it happens. You don't want your customers to know it before you know it. So I think the most easy, trivial way is creating a simple test. A test that only checks their APIs. Checks that the API is getting what you think and retrieving what you think. And it has none of your logic in it. So if they change something, this test will start to fail and you will know about it. Okay, so let's think about what we talked about. So the first step when integrating with other service would be reading the documentation and then trying their APIs. After that, we can start with the happy flow and then go over to the unhappy flow and deal with errors. And then the last thing would be test it, so we will know if they change something. So I think it's time, after you finish all your feature, to think about what you have learned. Because you worked with other people's API, you've seen their documentation, and you can learn a lot about it. Try to think, was it clear enough? Think about the name they used for their APIs and parameters. Were they intuitive? What about their exceptions? Were they informative enough? Take all you've learned and try to remember it when you build your own APIs. I would like to finish with a quote by Newton. So he said, "If I've seen farther than others, it is by standing upon the shoulders of giants." Thank you.
Hi everyone. Today I'm going to talk about how to properly evaluate a new database for your solution with more confidence. So my name is Natasha, and I'm a senior software engineer and architect with over 12 years of experience. And for the past 4.5 years, I've been working in Ruby Web Analytics and facing data challenges on a daily basis. I love software and system design, and especially working with data, and I find database products fascinating and inspiring. And at this point, I'll tell you my first disclaimer, which is that I'm not a DBA. However, in my years of experience, I know that choosing a database can be crucial when designing your system, which makes this task super important for every software engineer out there. And while the task of choosing seems straightforward, as software engineers, we more than often fall short performing this task, simply because we either fail to properly understand our data or we fail to properly evaluate the chosen database. So the scenario I'm talking about is when you have a new feature or system that you need to implement, and this feature introduces a certain complexity you do not have experience with. And this feature obviously involves manipulating, storing, and querying data. So if you're lucky, you get a solid PRD from your product team. And if not, you should go to lengths to fill the gap. But essentially, you should have a list of requirements, including what queries should be supported, the expected concurrency of them, how data is ingested, and what data volumes we're talking about. And you should know the expected SLAs and the requirements for data freshness. And this list will probably include a bunch of other things. And now, armed with this list, you continue to choosing a database. And you want to do a really good job, and you want to pick just the right one. So many times the choice of database will be straightforward. You will have your experience, your intuition, and usually the company you work in will have a group of already in use database and all at your disposal. So onto this collection, and let's assume that this is it. You start projecting your requirements. And while you do have experience working with them, because your feature holds this complexity that you haven't implemented before, you are unsure if either of these databases will fit the requirements. And so you start wondering naturally if there is a better DB out there. And you start reading and investigating. And pretty quickly, depending on your experience, of course, you are in danger of getting overwhelmed because there are a lot of databases out there and more are coming out by the year. And each database excels in different scenarios, and each database's homepage will state that it's absolutely the best thing for every single use case you have. So in short, you are even more hesitant than before. Because how are you supposed to come to the right decision without having experience working with these new databases? So take a breath and start at the beginning. And since obviously not all databases are even worth considering, it's a good idea to make sure you truly understand your data and you focus only on appropriate candidates. So as you all know, there are several database paradigms and there are a lot of excellent posts and sources out there on how to choose the right DB for your use case. And they vary between presenting and comparing different database paradigms, listing the pros, the cons, and exploring appropriate use cases for each. And you also have the deep dives into paradigms by examining the properties of specific databases, such as persistency, scale, and performance. But this is not that kind of talk, and I'm not going to talk about which database you should choose and how, but rather I'm going to focus on the next step, which is how you evaluate a database for your feature. So let's say you talk to some friends in the industry and you consulted with a bunch of companies about your use case, and now you have a leading candidate database that you think will be a good fit. So if this is a new database and not one of your go-tos, you're still scared because starting to use a new database is not always an easy decision for a company. It involves a leap which translates to money eventually, right? So it's hard coming to your boss and telling them, hey, let's choose this solution I have absolutely no experience with, but I think might be a good fit. It's not easy, and you wanna gain more confidence before doing that. But you're not sure what you should check, how do you start, and with what. And more importantly, how do you measure these elusive things that accompany any new technology, like ongoing maintenance and R&D time, and the solution's resilience in your setting, the flexibility. So if only you had the ability to glimpse into the future and to know how this database will actually function and behave with this feature already in production. That would be amazing, right? Because you would see how it behaves with a scale, with the proper data, you would understand the maintenance issues, you would already have experienced them, and then you would be done. But until quantum physics is more advanced, I guess, you should start with a POC. And I know this sounds pretty straightforward because we always POC a new technology before choosing it, and I'm not telling you anything that is new. However, when dealing with data and with databases, properly evaluating it involves more than just setting it up and testing queries. And for the rest of this talk, I'll go over a checklist that I gathered that you should definitely evaluate and score your database against in order to truly gain more confidence before deciding whether this is a good fit or not for you. And I will also share why this is not as straightforward as a regular POC, not in terms of time, investment, and even money, but why it's still very much worth it, and I hope that I will be able to convince you. So let's start. And what you'll start with is implementing a lightweight version of this feature, and you should include the queries and preferably the data ingestion. And by doing that, what you'll essentially gain is the ability to estimate the product fit and the technical limitations. So you will have to structure your data and construct your tables and indices and start writing the queries and make sure that all access patterns are supported by the query language, by the features of this database, and you want to make sure that the queries run in a decent time. You will also have to understand how to insert data into the database and whether this database is even suitable for your write and update needs. And what I mean by technical limitations is that you will find that maybe some specific features are not existing to support a specific type of query. Or maybe the way data is ingested into this database affects data freshness, for example. So these are the types of things you will learn to understand already at this stage. And now a good idea would also be to include matrix at this stage of implementation with some earlier thought about how you're going to benchmark your performance for later. And also another thing you want to consider is how flexible your solution is. So for example, consider any data alterations. What happens if you want to add more columns? What happens if you are required to support additional queries that are slightly different than the ones you know of, and see how flexible this solution really is. So now that you have a working implementation, you will want to start moving to testing performance and scale. So remember, you want to emulate production as best as possible in order to get the confidence you need. And if things were relatively easy until now, this is when it's getting complicated and it stops being just like the regular POC. So in order to test performance, you would ideally simulate production data volumes and production query concurrency. So for that, you will need to stream data into your database, and this could be a timely task. And at this point, if you feel data ingestion is a risk, it's definitely worth investing in implementing and testing data ingestion now. And if not, just choose the easiest and fastest solution, and you can deal with properly implementing it later. And you can use load testing tools to simulate query concurrency. And then you would want to time your queries to understand the performance of your implementation. Is it stable over time? Is it stable over different segments of your data? For example, say you have data that is associated for different customers. Try to see if you can optimize queries by maybe constructing the data differently, or maybe the queries a bit differently. And check if maybe some database configuration fine-tuning is needed to help boost your performance. For example, slightly different allocation of resources. And after you've done that, you want to move to testing scale. So the first thing you should understand is what scaling options are even available. Is your database the kind that scales vertically just by increasing resources like storage or compute? Maybe it's a solution that scales horizontally. And you want your database to be set up using the production deployment already and not locally, of course. And here the choices are usually between fully managed service, a semi-managed by your cloud provider, or fully managed by you. And for the deployment of choice, you want to understand whether auto-scaling is an option, is scaling done manually, how data is affected during scaling up and down. Is there a rebalancing operation that is required? Should this be performed manually? Is data availability affected during a rebalancing operation? And again, you will also want to simulate 10x data volumes or maybe 100x data volumes in query concurrency to experiment these scaling operations, and also to experiment how your implementation will behave for a higher scale. So until now, our evaluation concentrated on the actual usage of the database and its options and performance. And there are 3 more super important points you should include in your evaluation. And luckily enough, they are based on the work that you've already done. So hopefully it's mostly a matter of some calculations at this point and retrospective. So let's start with the first one, which is a very interesting point, and that is the cost. So depending on the database and the deployment, you should understand what you're going to be built for and what this bill is comprised of. And there can be several options here, because if you're using a database that is a fully hosted and managed service, you will be billed for a license. If this is a product that is hosted on your environment, an additional hardware cost should be considered. And by looking at this implementation that you already have, which is, like we said, very close to production, you should already be able to know what the required hardware is and what the pricing model that suits you is. And then you can just compute the expected price. And of course, this is an estimation, but it's a pretty good one by now. And of course, you can also try to emulate the 10x increase in volume and concurrency, so you can also estimate the expected price for future scale. Now, as promised, most of the work is done, so let's take a look at the last 2 points that are crucial to understand and that hopefully, after experimenting in almost production environment, you can score. So these 2 points are the maintenance and the learning curve. So take a look back and estimate them. Do you feel that this database was easy to learn how to use? Does it have a strong community you can consult with? Is it mature enough in terms of stability? How much maintenance did you experience? What kind of operations were required from you? So once you're done scoring all of these 7 points, take a step back. And do you feel differently about your database? Do you feel more confident recommending it for your feature? So regardless of whether your research will result in choosing or not choosing this database, which is also a viable option, you should definitely feel more confident with your choice. Because all of a sudden, this new database is not so new anymore, and you already have some experience with it. So I know this sounds like a lot of work, and let's put it out there, it is. It's also going to cost money for the company to do this, the setup, the hardware, the R&D hours, and you need to make this clear to your managers. And you won't always be able to do it all, let alone do it thoroughly and perfectly. But my best advice for you after doing this whole process recently at work is set yourself with concrete milestones for this POC and estimate what you can't check thoroughly. And I promise that as long as you will do at least some of the work, any work out of these things, your confidence will grow. And the more you do out of this process, the more your confidence will grow with it. And on a final note, please remember that there is no such thing as a bad database, only a mistreated one. So try to evaluate your database of choice as well as possible so you won't end up mistreating yours. Thank you very much.
Hey all, nice to meet you. This session is about what you should know before, but also after using cloud provider managed services. So hi, my name is Daphne Parush-Gueta. Nice to meet you all. And the last 5 years I've been working at Cybereason and currently as a technical leader. And while working at Cybereason, I worked on various projects with various architectural approaches. Many of those projects are based on the cloud managed services. So in this talk, I want to share with you my point of view on using cloud managed services. Let's start with definition. What is the cloud? If you're a developer in today's world, there's a good chance that your infrastructure is on the cloud. Today, 90% of the companies use cloud provider services. 60% of the workloads run on the cloud. 30% of the IT budget are allocated to the cloud. And those numbers are only expected to be increased in the upcoming years. If you are still not convinced that this is the future for the tech industry, the number 3 most paid job in 2018 was cloud engineers. So why should you use the cloud, or why companies adopting cloud so rapidly? Using the cloud provider allows you to move responsibility from you to the cloud provider. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from your cloud provider. The key benefits of using the clouds are, first of all, money. There's a lower upfront cost and pay as you go. You don't need to make large upfront investment in hardware and overpay for capacity you don't use. Instead of buying and maintaining your own hardware, you have all the infrastructure you could possibly need, and you only pay for what you use. The freedom to grow, scaling up and down based on your usage. You can scale those resources up and down to grow or shrink capacity instantly as your business grows and changes. Deploy globally. Cloud providers also make it easy to expand to new regions. Cloud providers have infrastructure all over the world, so you are able to deploy your application in multiple physical locations. Putting the application close to your end user reduces latency and therefore improve their experience. And sometimes for compliance, you must deploy your app in different regions. One good example is the GDPR. Focus and time to market. Bottom line, it gives you focus. You don't waste your time on tasks that are not your core business and others can perform better. The clouds free you from managing infrastructure, data center, and technology, so you can focus on what matters most to your business. So we are all set on what are the cloud providers and what are the benefits. Now let's talk about what are the different types of cloud services models. Each type gives you, the developer, different level of responsibility. Infrastructure as a service is the externalization of the infrastructure. Infrastructure as a service are, for example, virtual machines or file storage services. You can select your own VM based on your needs, like the numbers of CPUs, the memory size, disk size, but you will be responsible for the OS and the middleware and the applications that run on this VM. You can add more VM and delete once you're done with them, but it's up to you as a software developer to manage them and to scale them. PaaS is the platform as a service, externalization of the infrastructure, and the middleware application. Platform as a service provides you a platform, allowing you to develop applications without the complexity of building and maintaining the infrastructure. You as developer need to focus only on the application development. And SaaS is the externalization of the whole software. Software as a service. It's sometimes called on-demand software. Most of the time, it's being accessed by the end user via the web browser. In SaaS, everything is managed by the vendor. The infrastructure, the middleware, and the application itself. So you, as the end user, just need to use it. Gmail is a great example for SaaS. The Google team manages everything, and you just consume it from your web browser. To summarize, each of the cloud services models move more and more responsibility from you to the cloud provider. Cloud services help you to offload and outsource management, which helps you to increase your agility and reduce your time to market. And of course, there is also the on-premise approach, which stands for where you need to manage everything, and there's no cloud providers here to rescue. So, what did I learn from using cloud provider services? Is it also shiny and glory? Well, not, or not always. My first lesson learned. Lesson number 1 was that with great power comes great responsibility. When I choose to work with specific cloud managed service, I explored this service. I read technical blog posts on this service. I built POC on top of this service. And I verified that there is a perfect match between my use case and my technology challenge and the business requirements and these specific service capabilities. But I was educated to understand that together with choosing the specific service, I choose the whole ecosystem. You're asking, what does this ecosystem stand for? The ecosystem is the billing service, the security, roles, and permission methodology of the cloud providers, and many more. I needed to invest time on learning new best practices of the cloud provider. I need to adjust my CI/CD to use managed services. All the deployment process change. I need to redesign my automation framework in order to test communication with those managed services. It was suddenly new expertise that I need to adopt and learn into my development environment. The impact of using cloud provider managed service, specific service, was much wider than learning and integrating with the specific service. Good example for this, it will be the cloud provider billing service. I needed to learn how to read and use the cloud provider billing service, where to find all the reports, to understand them and to derive conclusion from those reports. And just like there are code writing best practices, there are billing management best practices that I had to learn. For example, budget managing with alerts, labeling my cloud resources, and a few more techniques and tools. So, apart from learning and using the real service I want to work with, I had to learn, use, and manage the whole ecosystem of my cloud provider. And there is a learning curve for those tools, and you will need to invest time on it. So just keep that in mind. My second lesson learned. The unlimited scale. Is it really unlimited? Sometimes it sounds like the cloud has the ability to scale infinitely, but I learned that there are limits, and the quota tells you how far you can push those limits. We faced quota limitation more than once. So before using any service, I recommend reading the quota limitations of the service and try to think about the future and the potential growth of your business needs. Imagine a big future with great success, your business grows 10 times. Does this service still fit your needs? Will you be blocked by the quota? If so, this is a red mark. Remember it and use it with caution. But there are some advantages of the quota limitations. First, it's in your face. It's available to you from day one. It's written black on white on the cloud provider documentations. So before you even start working, you just need to read it, and there's no extra effort from your side. Second thing is that some of those limitations might be solved soon without you doing anything. It might be part of the cloud provider roadmap, or it's only already available as a beta service. One more important thing to know about a quota is the differentiations between hard limits and soft limits. Hard limits are fixed. When you reach it, you're stuck in the wall. Soft limits can be modified by your cloud provider based on your needs, and it's negotiable. So there are limitations and there are constraints, and sometimes there's no match and there is no service that fits your needs. One approach is to create your own tailor-made solution. Sometimes combining together few services can solve it. So try to be creative, think out of the box, challenge the requirements, challenge the business needs, think of it and open your mind. My third lesson learned. We're back to money. You will be charged for your mistakes. Pay-as-you-go model brings a few new challenges to you as a developer. The cloud provider charges you only for what is being used, right? But what happens if you just didn't mean to use it? Remember, you will be charged for your mistakes. And again, with great power comes great responsibility. Cost explosion risk. In one of my projects, the load and the traffic was controlled by third party. So as a result, the build was changed without me doing I wasn't involved actively. So I always had to monitor it and to track it. Every day I look at the report. It was my responsibility. So one good practice to start with is budget alerts. But note, alerts only notify, will send you email notification or Slack notification, but then what? The charge still can grow rapidly. Another good practice is to set your scale limit. Some of the services let you to define the maximum scale. For example, maximum number of machines in Kubernetes cluster. And while you're setting auto-scale rule, do it with caution. Think about the impact. When it will reach the maximum, how your bill will look like, how much you will be charged for it, for the maximum scale. Again, it's your responsibility. And sometimes there's no way to escape it, and you will need to manage those limits programmatically on your own. To summarize, you will need to invest time on understanding what could go wrong, what is out of your control, and how it can impact your cost. List all the items and then go through the list, block and solve each one of the items. And think of it, limits are not always bad. So we crossed the finish line, and those were just 3 of my lessons learned. I have many more and still counting, but if I have to sum up in one sentence, I would say that using managed services bring you great power and great responsibility, and you will enjoy it. Thank you very much. Hope you enjoy it. Feel free to reach out. Bye-bye. Thank you.
Hi! First of all, I would like to thank you for joining me today. I highly appreciate it and I'm super excited. Are you ready to wrap your imperative mind around functional programming? I hope you do. My name is May. I am a software engineer and I'm a backend developer at AppsFlyer. And yeah, I'm a sworn Star Wars fan, as you can see. Let's talk about functional programming. In computer science, functional programming is a programming paradigm where programs are constructed by applying and composing functions. That is taken from Wikipedia. And that's it. That's all for today. Thank you so much for being here. Bye! I'm just kidding. No, that's not how we're going to talk about functional programming at all. But what we are going to do is I am going to show you some code examples that are taken from this game that I developed and is written in Clojure. I mean, the backend of this game is written in Clojure, which is a functional programming language, and the frontend was written in React.js, and it was developed by a talented developer, and his name is Roy Berkowitz. So thank you, Roy, for developing the great frontend. So this is the game. What you can see over here, it's a modified version of the game. What you can see over here is players that are moving in 4 directions and they cannot leave the screen. So let's talk about functional programming, and I will show you the code examples that describe how you can add a new player and how you can move a player, and doing all of that in a functional programming way. What does it mean? It means that you will not have any objects and you will not use any for loops. You will just use what a functional programming language gives you. Let's see what is that exactly. So, first things first, like I said, no objects. But what do we have? Well, we have key value map instead. So let's take a look at the first code example. What we have over here is a function. The name of the function is new player. And what you can see is that the first key in this map is named player ? This implies that this is a Boolean key value pair, and it means that this is a map that describes a player. All of the rest of the keys describes the other entities of this player. Since this is a multiplayer online game, if we have a lot of players, then we will have a collection that has all maps of all players. Next thing, we are going to have now pure functions. How do we do that? I mean, first of all, before how, what does it even mean? So, a function is considered pure if it returns the same result if given the same arguments, and it does not cause any observable side effects. Okay, take a look at this function, for example. When you look at this function, you immediately know that if you send the same R, you will get the same result. And this is because the output of this function is dependent solely on the input and not on anything else. Also, it does not cause any observable side effects. And what does this exactly mean? So, first thing, if you are reading from a file, for example, this means that you are dependent on something that is not the input of the function. It means that the content of the file can change, and then the output of the function will be different, even if I'll send the same input. Another example is random number generation. Let's say that I have a function that is just x times a random number, right? So even if I send the same x, I will get a different result because the result is dependent on random number generation. And last, if I modify a global object or a parameter passed by reference, this is causing observable side effects. Another thing is like changing a file, like writing to a file. That's also an observable side effect. So let's see an example of pure functions right here in our game. So the first function that we're going to look at is move player. So what move player is doing is just getting an input, calculating the steps of the player, and returning a player as an output. But how is that done exactly, and why this function is considered pure? So over here we have 4 parameters that we're getting as an input. The first one is the player's map, just like we saw before. It contains the X, the Y, and all sort of other data, but we're only going to use the X and the Y here of this player's map. Another thing that this function is getting is move X and move Y. These describe the amount of steps that the player has taken. And then we also get the window width and the window's height. And so this is so we can check for collisions with the window. So the player will not be able to leave the window of the game. So once we got this input, then what we're doing is calculating the new X and the new Y. And we're doing that by extracting the X and the Y from the player's map, and we're adding the amount of steps that the player took, and we're inserting it into new variables X and Y. This brings me to the next topic, immutability. Well, we got X and Y, and we got the player, and we wanted to change the position of the player. But how are we going to do that? Are we going to change the player's map, the map that we received? Are we going to change that? Not quite. Let's see what we are going to do. So, immutability. When data is immutable, its state cannot change after it's created. If you want to change an immutable object, well, you just can't. Instead, what you do is create a new object with the new value. And that's exactly how we're going to handle the player entity. What does it mean? So like I said, we calculated the new X and the new Y, and now what we want to do is to return a new map of a player. It means that we're not changing the input. We are just returning a new player's map. That's the output. So over here, where in the yellow markup, you can see that I am checking inside the if function. I am checking to see whether the X and the Y are valid if they're not smaller than 0. And then I also check to see whether the X and the Y are bigger than the window height and width. And if any of these happened, then I return a new player's map with a new key and value pair, which is collision set to true. And I am using the assoc function. The assoc function returns a new map with the player input values and a new key value pair. And if there was no collision with the window, or the X and the Y are valid, then all we need to do is use assoc once again to return a new player's map with new values set for X and Y. So remember, I am not changing the input, I am just returning a new map. So let's move forward to the next part of the game. This is a bit more elevated version of the game that we just saw before. Over here you can see that the player can move in 4 directions, and he can also collect the exceptions that are scattered around the screen. And the thing about collecting the exception is that we need to make sure that it's the same type of exception that the player has above its head as the exception that was collected. If the player collected the exception that matches the one that is written above his head, then we want this exception to disappear from the screen. Remember that, because that's going to be in our code examples. So, how are we going to talk about that? Well, we are going to talk about functions as first-class citizens. What does it mean? Okay, before I'm going to show you the code examples, what does it mean that functions are first-class citizens in functional programming languages? Well, in functional programming, functions are first-class citizens. This means that functions can be treated as values. They can be assigned as values, passed into functions, and returned from functions. Let's hold on to this part of assigning functions as values. So let's take a look at a code example that shows us the part where we check for a collision with the exception, right? Because it's a collectible, and then removing the exception from the screen. And the way that we're going to do that is, if there was a collision, it means that if the x and the y of the player is the same as the x and the y of the exception that was on the screen, right? Then we want to remove the exception from the exceptions list. I have an entire list of exceptions, and if one was collected, then I want to remove it from the list of exceptions because I don't want it to be shown on the screen anymore. Okay, let's begin. What you see over here is the collect function. And inside the collect function, what you can see that is marked in yellow, it's fn. This means that I'm declaring a new function, I'm creating a new function, and inside this new function, I am checking to see whether the exception type of the player matches the exception type that was on the screen. What I also do is I use another function that is called overlap. That's in order to see whether the x and the y of the exception and the player overlap each other. And this is how I detect the collision. What I'm going to do with this function that I just created, I am going to insert it into a variable named pred. And I do that using the led function. So I take a function, I declare it, and I insert it into a variable. That's crazy, isn't it? I mean, I think it's crazy. And this is the collect function. What is the next part? The next part that we want to do is to actually remove the exception from the screen in case there was a collision. So that brings me to my next point, passing a function into other functions, okay, as an input. How do I do that? Well, over here, you can see collectibles. This represents the collection of all the exceptions that are scattered around the screen. What we have also is pred. If you remember, pred is the function that we just declared in the line above, right? And we're taking both the collection and the function that I created, and I am sending it into the filter function. What I'm going to do with it, I'll explain in a second, but just notice this important fact, that I created a function and I am sending it as an input to another function. And that's because functions are first-class citizens in a functional programming language. Okay, next up, we have higher order functions. What does it mean? A higher order function is a function that either takes one or more functions as an argument or returns a function as its result. And if I want to be, more clear or to make it simple, I'll just say this. Because it's not very common to use for loops or any loops at all in functional programming languages. I mean, you can do that, but I mean, it's not the idea, right? What we do have is functions acting on collections, okay? So then what I can do, I can use filter to go over all of the items that I have in a collection. Therefore, I don't need a loop anymore because I have something that is already doing what it is that I need to do on all of the items that are inside a certain collection. And this is how we don't need loops. Clever, huh? So that's it. We have not used objects. We talked about pure functions. We talked about immutability. We talked about functions as values and higher order functions. And that's it. What I want you to take from this is, remember, in functional programming, we have functions acting on data and not data activating functions on itself. That's very important for you to remember that. And with that, I'm going to finish. And thank you for listening. I hope you enjoyed my talk. If you have any questions, feel free to reach out.
GraphQL, and when to use it. Hi, I'm Ella Sharkansky, and there is my dog, Kindle. I'm a software developer at Salto, and I use GraphQL every day, both in the backend and in the frontend. But enough about me. Let's talk about you. If you were Mark Zuckerberg in 2003. So, you're developing Facebook, and specifically the most important part of Facebook, which is the feed, of course. Now, let's say you're using REST API. And recall that REST API is an architectural style for web APIs, where we usually use HTTP methods to either get, update, create, or delete various resources. So how would you design the REST API for the feed? We'll probably have a /posts endpoint that returns a list of posts, and each post has text and creation date and many other details. And this works just fine. And after some time, you decide that you want to increase engagement, and you have this great idea. Add comments, because you believe that if people will see comments on the feed, then they will want to comment even more. So you want to show the top 2 comments of each post right there on the feed. How would you design the API? You'll probably add a field comments to the /posts endpoint, and this field will have the top 2 comments. And this works great. And after some time, you decide to hire a product manager. And she looks at the site and has this really great and innovative idea. Remove comments, because the feed is too cluttered and it should be nice and clean. So, what would you do now? You can just not show comments, but if your backend still returns comments, then it's pretty wasteful. So you want to not return comments from the backend. But this is a breaking change in your API, and it also requires some work in the backend, so it's not that easy. Anyway, you decide to do this change. Maybe you are creating a new API version just for this, and when you're done, your product manager has another great idea, and it's really groundbreaking this time. Add comments, but only for the website, because the app should still be clean. What would you do now? And note that this is not an easy question, because there are many possible solutions, but they all have disadvantages. So let's go over some possible solutions. Solution number 1, the /posts endpoint won't return comments. And then in the website, you'll have to ask for the comments of each post separately. This is called underfetching, because the /posts endpoint doesn't return all of the data that you need. And having to send these many requests, one for each post, is both slow and inconvenient. So let's look at solution number 2. The /posts endpoint will return comments, but in the app you just won't use them. This is called overfetching, because you're fetching more data than you need. And it wastes time because the backend has to calculate the top comments of each post, and then you just don't use it. And it wastes bandwidth because you are sending these comments to the client, and the client doesn't need them. It can even waste your client money because some clients pay for the bandwidth. So, solution number 3. You can have a parameter view, and the detailed view will include comments, so you will use this view in the website, and the standard view won't return comments, and you will use it in the app. But the thing is, there are many possibilities. Maybe you want to show the top likers of each post, and maybe you don't. Maybe you care about the author, and maybe you don't. So you'll end up having many views, like simple and simpler and full. And each view will be coupled with your specific frontend in that specific point in time. So if, for example, your detailed view includes the top likers of the post and the standard view doesn't because you don't show that information in the app, and then you decide that you do want to show that information, that even though your backend already returns top likers in the detailed view, you'll still have to change the backend in order to return it in the standard view. So every frontend change will require a backend change. And in the end, you'll have many views, and you won't even remember which views you have and which values each view returns. So this is both confusing and not scalable. And the thing is, you can count on your product manager to keep having these great ideas, like to show the top likers of each comment, or to support Smart TV, which is a completely different view, or to support external API consumers, meaning people that are using your API for things that you don't anticipate in advance. And that's why your backend has to support in a convenient way many use cases. Now, let me introduce you to GraphQL. GraphQL stands for Graph Query Language. And I'll first explain some main concepts in GraphQL, and then I'll explain how GraphQL solves all of the problems that we have just discussed. So, the first main concept in GraphQL is the schema. The schema is basically a description of your API, and every GraphQL API must have a schema. In our case, this is what the schema might look like. So first we have the top level type query. And here we have our top level queries, which is the posts query that returns a list of posts, and the single post query, which receives an ID and returns a post with this ID. Exclamation mark stands for not nullable. Now, the type post has ID, text, and a list of comments, and the type comment has ID and text. Having a schema has many benefits. For example, the schema serves as a type system, meaning that GraphQL can generate from the schema types in our own language automatically. So it can generate the post and the comment type and many other types in C# or Java or TypeScript or any language that you are using. And another benefit of having a schema is that it serves as a contract between the client and the server. So when you are about to develop a new feature, the backend and the frontend can first decide on the schema together, and then they can start developing the features simultaneously because they already know what the API is going to look like. The third benefit of having a schema is that it allows introspection, meaning that if I'm about to use a new GraphQL API that I don't know, then I can simply look at the schema, and that will provide me with all of the information I need about which queries I can ask for and which return values I'm going to get. In fact, how do you query a schema? Simple. You send a post request to /GraphQL. So there is only one endpoint, and you can get everything you need from that endpoint. And then in the body of your request, you send the query that you want. In this case, we want posts, and for each post, we want the text and the comments of this post. And for each comment, we want the text of the comment. The result of the query looks exactly like it. So we first have a field data, and then we have posts, which is a list of posts. Each post has text and comments, and comments is a list of comments where each comment object has text. So the result and the query are very similar. Now, if you don't want to return comments anymore, then simply don't ask for them, and then the backend won't return them and won't calculate them. This depends on the backend implementation, but it's very easy to implement this way, so the backend will only calculate comments when you explicitly ask for them. So as you can see, GraphQL solves many problems. It helps you avoid breaking your API, because if you don't want comments, you simply don't ask for them, and there is no need to change the API. The schema remains the same. Also, GraphQL solves overfetching and underfetching, because you get exactly what you ask for. Now, you may be asking yourself, how does this work? How come GraphQL doesn't calculate comments unless we explicitly ask for them? How is it implemented? Is this magic? Well, no, it's resolvers. And let me show you the TypeScript implementation of our resolvers for the feed. So first we define this object that describes our resolvers, and we have the top level resolvers, which is a single post and posts. And then we have the comments resolver, which is in the type post because comments belong to a post. Now, note that we don't have a resolver for text, for example, because in this implementation, we will always calculate the text of the post when you ask for a post, but we will only calculate comments when you explicitly ask for them. That's why we have a resolver for comments. Now, what is a resolver? A resolver is just a function. And let's look at some implementations. So first, the posts resolver. It doesn't need any arguments, and it returns a list of posts simply by calling a function, all posts, and this function probably queries our database and maybe does some more logic, and then it returns a list of posts. And note that we are only asking for the ID and the text fields of each post, because at this point, we are not calculating comments just yet. That's why we have the comments resolver, and this resolver will only run when you ask for comments. The resolver accepts one argument, which is the post that these comments belong to. So every resolver can accept its parent as an argument. The parent of comments is post. And then we just return a list of comments by using the ID of the post. And then the single post resolver is also very easy to implement, so I won't show it here. So as you can see, implementing resolver is simple, and GraphQL is very powerful. So you may be asking yourself, is GraphQL perfect? Well, not exactly, but I won't go over its disadvantages in this short presentation. However, I will mention two challenges that I have experienced with GraphQL. First, the learning curve, because to learn GraphQL, I first had to study the specification of GraphQL, and then I had to learn the specific packages that we're using at Salto, which are TypeScript packages. So I had to learn the TypeScript implementation in the backend and also another package for the frontend. And GraphQL is pretty different from REST, so there was a lot to learn. Now, the second challenge is the maturity of GraphQL, because GraphQL was initially released about 5 years ago to the public, and its stable release was about 2 years ago. So it's not as mature as REST. However, the community is very active, and GraphQL is maturing by the day. In fact, who is using GraphQL? Many companies, like PayPal, Twitter, Airbnb, GitHub, and of course, Facebook, who invented GraphQL. And they're using GraphQL for a good reason, because as you've seen, GraphQL solves real problems. It helps you avoid breaking your API, and it also solves overfetching and underfetching. So the next time you are designing an API, I hope you consider using GraphQL. Thank you.
Back in 2015, when I was still a young computer science student, I started to work at Intel and rapidly jumped into the world of lint and compilation. I joined the team that developed a lint tool for hardware design. In the beginning, everything was new to me. Lint, which at first sight looked innocent or even marginal, appeared to be a powerful, fascinating tool, interesting to develop and with major impact. My name is Maayan Choval, and I'm a software engineer. Today, I would like to give you a glimpse into the world of lint as I find it. We will talk about what is lint, how does it work behind the scenes, and how it is applicable in software and in hardware. Lint. It is the general name for software that aims to analyze and verify code correctness statically. Means by looking at the code only and without actually need to run it. It is usually follows a bench of rules, determines what is considered to be a good structure of a code. The term lint was derived from the name of the tiny bits of fiber and fluff shed by clothing, in resemblance to those tiny little defects that sometimes get all over our clothes. In code, little mistakes, stylistic inconsistencies, or even dangerous logic are things to get rid of. This purpose can be achieved using a lint tool. The term lint originates from a Unix utility that examined C language source code in 1978. So we discovered what lint basically is. Let's see how does it actually works. There are two main parts of lint tool. First are the rules, which are dedicated to check and analyze a range of requirements. And second is the compilation process. Lint is based on a compiler, and so during different phases of the compilation process, different aspects of the program are being analyzed. There are linters for both compiled and interpreted languages, and today we will focus on the compiled ones. Let's have a short reminder on what is a compiler. Compilation is the process of taking code written in language A and convert it into target language B. A known usage is converting a code written in some programming language into a machine-level language in order to create an executable file. Another usage is compiling a code that describes hardware design and translate it into the target of hardware physical model. We will go over some of the phases of a compiler on high level to see what information the linter can conclude and analyze at each phase of the compilation. First phase is lexical analysis. In this phase, the compiler reads the sequence of characters in the program as tokens and converts them into meaningful lexemes. This is the basic phase of the compilation process, where the compiler scans the code. Here, the character stream is grouped into meaningful sequences called tokens, and entries of the corresponding units are being created in the symbol table. Second phase is syntax analysis. In this phase, a syntax tree is being created, checking if a given input is in the correct syntax of the programming language or not. This phase is all about figuring the structures in the code. Here, the compiler determines whether or not the text follows the expected format of a specific programming language by constructing a parse tree with the help of tokens from the previous phase. The linter can then use information gathered by the compiler so far in order to collect and identify issues about all in regards to correct structures of the language. For example, unbalanced parentheses or a missing semicolon. Third phase is semantical analysis, checking whether the parse tree constructed follow the rules of the language. Here, the consistency of the code is being checked. Using the syntax tree from the previous phase, along with the symbol table, the compiler verifies that the given source code is semantically consistent. It will check, for example, for type mismatch and incompatible operands. The linter can then use this information to alert about issues in regards to semantics of the program and about issues derived from the syntax tree, such as incompatible value assignment, infinite loop, or even unreachable code. We focused on some of the phases of a compiler and discovered how can a linter benefits from them in order to analyze code. Let's see how lint is being used in software programming. A linter is commonly used as an internal tool of an IDE, based on the requirements of the programming language that is being used. When using an IDE, you probably have encountered the capability of underlying issues in the code as you type. This is the result of a linter running in the background of your IDE, allowing highlighting, underlining, or identifying problem areas in the code before running it. Another usage of a linter is as a standalone software that is based on custom-made requirements rules, which depends on the specific project definitions. The linter then follows the compiler API to identify issues during the compilation phases, same phases as we talked earlier. Let's have a small example. For the example, I will use C++ programming language, but this can be done in any other programming language. Say we are currently developing a game, and we have a building block of a figure class. We want our software to be in good practice for this project, so we decide to have a requirement of each figure object must start with the letter F. So we want to get an error if this is typed, and we want this to be the correct syntax. Say we are using a lint tool for the project, and we want our lint tool to handle this requirement. We remember that lint is basically enforcing rules. So first, we need to have a matching rule for the above requirement. In order to write such a rule, let's see what information we need. We need to know if an object was created and of which type. The question is whether we have this information and when. So when do we actually have the information about the type of an object? To answer this question, let's remember what are the compilation phases the linter is based on and what it can achieve in every phase. In the lexical part, the compiler reads the characters and gathers them into tokens, and then illegal tokens are being recognized. In the syntactical part, composing a parse tree, figuring the structures of the code, then broken structures are revealed. And in the semantical part, the compiler checks if the code conveys an appropriate meaning. In this phase, we saw an example of type checking. While having this in mind, can you tell after which phase the compiler will have the needed information for our rule? The information about the object's statically typed creation? This will be after the semantical analysis phase. Well done to all of you who got it right. So, we figured out when the compiler will have all the necessary information about the objects in the program. Now let's draw an outline of our rule in pseudocode. First, we need to fetch all objects of type figure. And to do that, we'll base on the information from the compiler. Remember, this information is available after semantical analysis phase. Then, for each figure object, we'll check whether or not it starts with an F. If it is not, we'll flag a violation of this rule. So, in conclusion, we got a requirement that is based statically on the code, and we used lint mechanism to achieve it. So far, we talked about how lint is used in software programming. Let's see how does it work for hardware design. Like software programming languages, there are several languages of hardware description that are used to create a hardware design. This group of languages is called RTL, Register Transfer Level, which includes, for example, System Verilog and VHDL languages. In resemblance to software programming languages, also hardware description languages are being compiled. This time, instead of creating a binary code, the compilation process will create a hardware modeling made of gates and wires. In analogy to what we saw in regards to software programming, in hardware design, there is also the need to verify the code. Lint has become the generic term given to design verification tools that perform static analysis, based on a series of rules and guidelines which reflect good coding practice. In hardware, lint can be even more powerful than in software, recognizing input-output mismatch, race conditions, incorrect usage of blocking and non-blocking assignments, set and reset conflicts, or even deadlock conditions. In RTL, the building blocks are modules, which includes port, data type, functionality, and timing. In software source code, we saw earlier an example about issues of the syntax itself. We wanted to force a requirement on the code syntactically. In hardware design, by only reading the code, along with the given constraints of the project, such as timing and area, we can actually conclude a lot about the design. Let's take, for example, a design which is built of two modules. Each one is connected to the other. The linter can detect, for example, issues of input-output mismatch between the modules. And when talking about circular dependency, we can think of some issues that might arise. A linter can take into consideration clock resolution and can detect race or even deadlock conditions. Different rules can be categorized into different severities, depends on their importance. So when having a violation of some rule, the user can decide whether to alert it immediately or if it can wait. For example, when talking about syntax rule that checks indentation of the code, it will probably be in low severity. And for example, rule which is checking for suspicious structures in the code that might cause a critical bug will be categorized as high or even showstopper severity. Another aspect for lint in hardware design is the fact that it can detect and prevent bugs before simulation of the hardware. So as a result, it reduces the time of the overall production process. And when talking about hardware for autonomous vehicles or medical products, getting the ultimate coverage of all edge cases can actually save lives. To wrap it all up, we talked about lint, a static analysis software, which is based on the phases of a compiler. And we focused on some of these phases. We saw how lint can be dedicated for the analysis of program written in multiple programming languages, both for software and for hardware. And now that we all understand the strengths and the capabilities of lint for various use cases, we can all go back to our favorite IDE, confidently use it, knowing what's going on behind the scenes. Thank you all for listening, and feel free to contact me on LinkedIn.
Hey, I'm going to talk today about over design. I'm Rona, and I'm a software engineer and a manager. I'm working at Mixtiles, and you can find me on Twitter at LangCareerRona. I want to start up with a short story about two groups of people, a group of engineers and a group of teenagers that were giving a mission to cross a river. So both groups sat down and start thinking on how they gonna cross that river. So the group of engineers came up with a solution to build a bridge. They start drawing their bridge and calculating the loads the bridge gonna have, and came up with a massive construction plan. And the other group of teenagers came up with a solution to build a boat. So they did it. They built a boat and they crossed the river. And after they got to the other side, the group of engineers were still planning and drawing and designing their bridge. So let's talk about over design. When we're building a two-story building, we don't set the foundations for the 50th floor, right? The same should apply for software design. We want to keep things as simple as we can. It will help us along the way. When we're over designing our system, we pay double. First for developing time and second on maintenance. Not to even mention the product changes we're going to have along the way that will add more time and more complications and more maintenance. In this talk, I will give some tools for identifying and over design and how to avoid it. I'm going to give some examples, and each example will have a guiding question. And in the end, I'm going to talk a bit about some do's and don'ts. So our first guiding question is, do we really need it? My team were asked to build a system to find data duplications. So we sat down a few engineers and tried to solve this problem and design a system for it. First, we had to deal with how to find the data duplication, and second, we needed to figure out what we're going to do once we found the duplication. Do we want to take the newer data, or do we have another way for figure out which data is more reliable? And we've sat for a few days designing and brainstorming, and then we've presented the design to the rest of the team, and they liked it. We had some comments, but they liked it. And after a few days, we had a meeting with the customer that gives us the data with the duplication. And in this meeting, we figure out that the customer can give us the data without duplication. So do we really need it? Not always. Guiding question number 2, who is going to use it? In a different company, my team was responsible on designing a new and improved API for one of our services. We had a really long list of requirements. So again, we sat down for designing the new API. The list of requirements, some of the requirements were for the API to be very generic. It should have fit all our service users, to have minimum restrictions on the parameters and on the body. And it caused us to deal with a lot of edge cases. But we did it. We came up with a design and we've implemented it. And after a few months, we've launched the system, the API, and it was great. We were really proud. It was very stable. And after a while, it turns out that we have only 2 users for our new and improved generic API. So who is going to use it? You need to think about it. Our third guiding question is there a simpler way? So imagine you're working in a small startup and you're only 3 developers, and you start designing your system for weather forecasting. And you start drawing on the whiteboard. You're going to have one service for crawling and one service for data, for handling all the data and calculating, and another service for presenting the forecast. And it's a really good design. You present it to your CDO, he approves, everything looks great. But in this example, I want to show that even microservices, which is a great architecture, can sometimes be over-designing it. You need to ask yourself, is there a simpler way? And in this case, probably 2 services can totally be enough, or even a monolith. Of course, you need to have it separated to modules. You do need to keep in mind that maybe one day you will want to split it. But currently, you're only 3 developers. You're a small startup. You don't know what you're really gonna need in the future. So start simple. If in 6 months your startup still exists and you have a growing number of customers, go ahead and split it to microservices. But currently, do the simplest thing you can possibly think of. So, some do's and don'ts. The first do is focus on the problem. Always have the problem you're solving in front of you. It will keep you focused. The second one is keep it simple. When you're designing your system, start with a simple design and keep it as simple as you can. Even after you're launching your system and you're designing a new feature, you always need to have in mind to keep it simple. And my don'ts is don't plan for theoretic needs. Think just on the near future. Let's go back to the river story. How could you avoid over design in this case or in any case? All you need to do is ask yourself 3 simple questions. First question is, do we really need it? Do we really need a bridge to cross a river? Probably not. Who is going to use it? If you have cars crossing the river, sure, go ahead and build a bridge. But if you're going to cross it, you don't need an entire bridge. And is there a simpler way? Of course there is. You can build a boat, you can swim. Just think of a simpler way. So I hope after this talk and when you next time you're gonna build your system, the 50th floor foundations won't be set unless really needed. And I want to finish up with a quote. Always implement things that when you actually need them, never when you just think you may need them. Thank you.
So, about a year ago, a friend sent me these comics, and it's about this developer. He writes a feature, and he wants to release it, like a beautiful butterfly, rising from stage into production to serve clients, but bam! There comes the QA with a bug, and all the happiness is gone. My goal in this lecture is to help this developer to keep on smiling. I present techniques and tips and states of mind that can help you to debug faster, better, and to be predictable, so you will know exactly what your next step is at every point of the way. By the way, hi, my name is Ella Shir. I'm a software engineer. I'm in love with software architecture, and I have this tech blog called Shir Engineer. You are welcome to check it out. My current job is writing real-time multimedia systems, where a bug can be the video is all colored green, there are no errors in the log, the system looks great. Where do I start? And at this point, I realized that we don't talk enough about debugging. I didn't learn debug skills in my computer science degree, and in the industry, I spent a lot of time learning Python, which I love, and other technologies, and maybe reading about clean code or seeing lectures about the design patterns. But I didn't invest time in solving problem skills, and I think that we should do this. We should get better at problem solving. And I have three different motivations why we should get better at debugging. The first one is don't bring me down. Sometimes we have negative feelings related to being assigned a bug. Maybe we feel guilty that we created a bug in the first place. Maybe we don't like solving problems and we feel that we are not very good at it. And that instead of solving a bug, I would prefer to write a new feature. So the first motivation is to get rid of the negative feelings that surround this issue. The second motivation is just get the job done. I want to do the assignment to solve the bug and do it as fast as I can and as efficiently as I can. And through this lecture, I will talk about different success criteria that we may have to the definition of done. The third motivation is about becoming a pro, because I want to get better at what I do. I want to be a better developer, a better engineer, and I can use bugs as an excuse to get better at my abilities and to sharpen my different skills. And I will give you some tips about this as well. What is the life cycle of the bug? So first of all, we observe a problem. This can happen at different stages of the development. Sometimes it's by QA or by a client in production, but it can also happen when I write new code and I try to run it, and I understand that something is not right. From this point on, I'm debugging. So after we saw that we have a problem, we want to find it. And we usually do so by gathering information or trying different things to understand where the problem is. So we go back and forth trying to gather information and find the problem. After we finally find it, we fix it, test it, and then we create more bugs. And it's an important statement because we need to understand that creating bugs is part of creating. We develop and we are not perfect, so we make mistakes, and this is okay. We should not feel anxious or guilty about it. Let's discuss more the part where we observe a bug. And for this, I have my imaginary friend, Sam. Sam is a developer. We have conversations mostly in my head because the bug that QA found was that the GUI showed 200% of upload. Do you know how to fix the bug? What you should do now? And Sam started to think about it in my head. The only real solution that I had to tell Sam is that we should stop guessing. When we approach a new bug, we should have a clear definition of the problem, what exactly we should solve. And usually using a list of steps to reproduce will help us very much in this part, because there may be other bugs in the same code, in the same area of the code, but we don't want to touch them right now. These kind of things can make us dwell and get lost very easily. The other thing that we should have is a clear criteria for success. What should I do in order to finish this mission? Like in the 200% GUI problem, it feels that the product team should help us to define what should happen in this case, because the feature is not exactly defined at this part. Another problem, for example, can be that the system doesn't load fast enough. So I have clear steps to reproduce. I restart and I check how long will it take the system to load. But what is my success criteria? How much time is it enough for the system to load in? How do I know it? These questions may seem trivial, but they actually help us to prevent from getting lost, because sometimes we rush too fast into the bug itself because maybe we know exactly where the problem is, but we didn't stop and define the success criteria. And then we end up having the client or the product team not happy with the solution, and the bugs get back to us. So this is important to do in order to prevent frustration of ourselves and everyone around us as well. Look at it this way. If the problem and the success criteria are very clear, it shouldn't take long for you to define them, and then you can move on. But if they are not clear, so you definitely should invest the time in making this clear, not just for you, but everybody else you work with. I want to tell you another story. This time it's mine and it really happened. I was dealing with a time-seeking thinking package, specifically replacing one called the NTP to another one called PTP on a Linux-based server. After writing some code and replacing the library, I had a bug. And it goes like this. Disconnecting and then reconnecting the LAN cable caused a time jump on the machine. It kind of made sense because it was related to the packages that I was replacing. And I had clear steps to reproduce. I know exactly what to do. And I jumped into the debug process. I would write some code, deploy, and go to the laboratory where the machine was. I would disconnect and then reconnect the LAN cable and run back to my PC to see the system logs and keep on debugging. It didn't solve the problem on the first try, so I added more logs and I checked more things. Then again, I had to run to the lab, disconnect and reconnect the LAN cable, and run back to my PC to keep on the debug. And so it went on and on and on and on. And I hope that you feel me when I say that I was quite annoyed. Not because I was too lazy to get up and go, but because all this running around in circles really chopped off my train of thoughts, and I was out of focus. And each time that I had to go and I went back and I got confused about what step was I trying, or what log did I add, or what should I be looking for right now. So I obviously wanted this cycle of running to be shorter. And my first idea was to bring my laptop to the laboratory with me, so I wouldn't have to go back to my PC all the time. It was okay, but was there a more technological solution for this issue? So I said, let's Google it. One of the very first results in Google about simulating the issue of reconnecting a LAN cable, I stumbled upon this script. IP-link set ETH0 down, sleep some time, and then IP-link set ETH0 up. That's it. It was this simple, and I no longer had to run anywhere. What I actually did in this story is to create a faster debug cycle. A debug cycle is the time passing from having an idea or even wanting to add some print or see some variable state in the system to actually seeing the result. It includes the code you have to write, build, deploy, run, reproduce the scenario, and observe the bug. We compromise because looking for a solution, looking for a shortcut that will help us to reduce this time also takes us time. And while I Google a script that will help me to simulate the problem or not to spend 5 minutes on deploying, I feel like all this searching and Googling isn't helping me to solve the bug. It's just for my own personal comfort. It's not for the bug solving. So maybe I shouldn't waste time on this. When I shorten the debug cycle, I reduce the cost of an attempt. Each debug cycle is an attempt to solve the problem or gather more information about the problem. And if this time is very long and I get lost in the art of the debug cycle itself, in reproducing the problem and everything around it. But if the cycle is short, I can run, I can build my logic and move on with my own thoughts and not to dwell on the logistics around it. I'm busy at the real thing that I should be doing. When the debug cycle is short, I can allow myself to take 1 or 2 wrong directions because it's not a big thing. The time I invested in it was very short. I can allow myself to be creative and go thinking out of the box or try things that I don't really think are the problem, but I just want to know that the problem is definitely not in this part. So I gain certainty and I can allow myself to do this if the attempt doesn't cost me much. So just before fixing the problem, we stumble upon a difficulty. And there are all kinds of stress that we need to close this bag as fast as we can and to move on. But this is a risky part because it may also create a technical debt. So when we approach to actually fix the bug, we have to keep in mind the same principle that guide us when we develop a new feature. Things like object-oriented programming, solid principles, clean code, doing design review, and generally choosing the right technical solution for the problem. So we chose a solution between a couple of options, and we implemented it. My last tip is about creating more bugs. Well, it is my last tip, but it's not about creating more bugs because I think that we are all going to do it anyways, and it's completely okay because it's just a natural part of writing new code. One of the ways to become a great developer is to learn new tools and to improve constantly. It can be learning new debuggers, of course, because we are talking about bugs, but more than that, it's a chance to write a Python script if you're not a Pythonist. It's a chance to write a shell script if you're not familiar with it. If I did all my bugs as fast as I could, but I didn't learn anything new, so my 99 bug will take just as long as my first because there was no progress that I made. And this investing of time is exactly what is going to make you really great at what you do. The 3 motivations that we started our journey with were to gain skills and knowledge that will stop bugs from bringing us down, skills that will get our job done and that will help us to become pros. I hope that this session got you a bit more enthusiastic about the art of debugging. And if you're interested, you can check out my blog that has some more great tips about what great developers do when they debug. Thank you for being with me, and goodbye.
Wow, what a fabulous first day. So many beautiful sessions, so many inspiring women. Thanks again to all of our amazing sponsors. We truly couldn't have done this without you. All of these companies are companies that actively support diversity as part of their agenda. Thank you for being part of the change and helping us to make sure these incredible voices are heard. Thanks to all of our speakers, our keynote speakers, event handler for producing the event, Microsoft and the Ba'ot community for the Academy course, and to all of our course mentors and instructors. Be sure to follow us on social media. Invite our speakers to speak at your next event, register as a speaker on our platform yourself, or register to our next round of the Speakers Academy. My name is Moran Weber, and on behalf of me and Women on Stage, we really hope you enjoyed yourself, and we're looking forward to seeing you tomorrow. Bye!